So the last type of limacon is going to be when the absolute value of A is greater than or equal to the absolute value of 2B. The limacon is going to be considered to be convex. So we're going to study the convex limacon. So using Desmos, let's put these 5 polar curves into Desmos, and we're going to examine, is there a difference between A and negative A? Is there a difference between B and negative B? And let's also look at the orientation of positive cosine, negative cosine, positive sine, and negative sine. So to determine if there is a difference between A and negative A, we're going to want to compare the first two equations, r equals 4 plus cosine theta, and r equals negative 4 plus cosine theta. So let's look at 4 plus cosine theta, and this is almost a circle, okay? What we've got going on here looks very similar to a circle. Oops, sorry. And if we think about this, this positive cosine means it's opening to the right. So where we see the convex part is actually right, it's happening right here. So let's compare that with negative 4 plus cosine theta. Okay, so I'm going to turn that one on. And if you notice, if I take it away, now we just see the red, the first one. If I put it on there, they are the same. Okay, so is there a difference between A and negative A? No, there is no difference. Now, let's check if there's a difference between B and negative B. So we're going to want to look at this first. Okay, so notice here's the convex part of this right over here. Okay, if you notice, this is to the left by 3, and it has an entire length of 8. Okay, and we're going to want to compare it with this third one here to see if B being negative changes it, and yes, it does. Okay, the blue is the third curve. So let's take away the red one, the first one. Now let's look at 4 minus cosine theta. So here's the convex part over here. Notice it's 3 units from 0 to the right, and it's got a length of 8. Okay, and it's opening, this is the convex part, it's opening to the left. So is there a difference between B and negative B? Well, look at that, look at that. The answer is yes, its orientation changes. So now let's look at 4 plus sine theta. So we know 4 plus cosine theta, if we go back to the first one, okay, the convex is to the left and it opens to the right. When B is negative and it's cosine, the convex part is to the right and it opens to the left. For 4 plus sine theta, okay, if we think about this from what we just studied with the dimpled limacon, the convex part should be down from 0 and it should be opening up. Okay, there it is. And for minus sine of theta, convex part is going to be above and it's going to be opening down. So the orientation is just like the dimpled limacon. So what we write down in our notebooks, is there a difference between A and negative A? No. Is there a difference between B and negative B? Yes, the orientation changes. And for positive cosine theta, negative cosine theta, positive sine theta, negative sine theta, it's the same as the dimpled limacon, but the location of the dimple is now this convex shape. So let's see how similar it is to being a dimpled limacon. Okay, so we're going to graph these 4 polar curves. Notice the absolute value of A is greater than or equal to the absolute value of 2B for all of these 4 in part B here. So we're going to look for the similarities. So the similarities are going to be the location of the dimple and the entire length of the limacon. So if you thought about it, the dimple location was the absolute value of A minus the absolute value of B, and the length from the dimple to opposite side was 2 times the absolute value of A. So let's see if that still holds true. And then what is the only difference between the dimpled limacon and the convex limacon? So let's go ahead and put this on Desmos now.